amplifier that's going to produce 50 watts by 4 at 4 ohms, it should do 100 watts by 4 at 2 ohms. So when we bridge it, that means we should pretty much be able to add this together to get 200 watts by 2 at 4 ohms. So why does this make a difference? So take this scenario here. Let's use our KXA 400.4. It's 50 watts per channel at 4 ohms, which is why I use this. So if I connect this to a set of components and I take the passive crossover out, I get 50 watts to each tweeter, I get 50 watts to each mid-range. And of course, you're going to use the active crossover in the amplifier, but when you do that, you've taken away the passive crossover, you've taken away possibly 2 things. One thing for sure is the tweeter protection. The second one might be what we call Zobel impedance compensation, which will actually smooth out the frequency response. So when you take the passive crossover out, you lose some of that protection and some of that circuitry that's there to smooth out the response of the tweeter, make it more natural sounding. When we go down here and we bridge this, we get the same power. We're still at 4 ohm load, but we're going to leave the passive crossovers in this time. So now I'm getting 200 watts to each of the speakers. That doesn't make sense, does it, Jacob? 200 watts to each of the speakers, that should be 800 watts then, right? Not 400 altogether? Well, it's really kind of interesting the way it works. And with the passive crossovers, what the passive crossovers are going to do is they're going to divide that frequency range up. So you're still going to get the 200 watts each tweeter. You're going to get 200 watts each of the mid-ranges. You're getting 4 times the power with the same amplifier and the same speakers, not by going and leaving it in the 4-channel mode. Now, if you need to do time alignment or you want to do active crossovers, obviously you got to stick in the 4-channel mode. But if you're going to have a set of high-end coaxes or high-end components where the tweeters and mids are close together, you can bridge that so you literally get 4 times the power each speaker, which means more headroom, more clarity, more louder, which is more gooder, right, Jacob?
Absolutely.
So how does that work? How do you get 200 watts to each speaker, the mid-range and the tweeter? So let's just look at the frequency band with the passive crossover. So you got the mid-range, and you got the tweeter output. What the passive crossover does is it actually adds resistance. So in the mid-range, as you go higher in frequency, it adds more resistance. And as the tweeter goes lower in frequency, it adds more this way. So you get what you call a crossover point. You get a little bit of an area where there's also a dip. So by using the passive crossover, if you have this set up down here with a minus 6 dB setup, you're going to get an average flat response because at this point you're doubling the power and you're doubling the speakers playing the same frequency. So with the minus 6 dB, you actually get a flat frequency response if the crossover point is down 6 dB. And that's a Linkwitz-Riley crossover. Now, when we get into a Butterworth crossover, it's still very similar, but it's going to be at a higher frequency. It's at minus 3. So now I'm going to get a 3 dB peak. So what that means is that's how a passive crossover works, the difference between Linkwitz-Riley and a Butterworth crossover. But more importantly, how do we get 200 watts to each of these speakers by doing that? And the way it works is you got 200 watts going to the mid-range at this frequency range, and you'll have 200 watts going to the tweeter at this frequency range. So while each one is getting the 200 watts, they don't really overlap. And of course, the power is going to go down as you go up or lower frequency, depending if it's mid-range or a tweeter. So that's really how the passive crossovers allow you to run incredible amounts of power out of those speakers without losing power and about having to go to the 4-channel mode. So depending on your application, if you just got good 2-channel setup up front, you got a 4-channel amp, bridge it all the time. Most car audio amplifiers today are rated at maximum power at 2 ohm stereo. It's just one of the power ratings, that's the way we do it. Now, when you get into like our power sports amplifiers that we have in the tank up here, we're rating those amplifiers at 4 ohms. So the 100 or 400.4 does 100 watts per channel at 4 ohms. So we're trying to push the industry back into that 4 ohm rating because how many coaxes are 4 ohms?
Most of them.
Yeah, how many are 2 ohms?
Not
almost none.
Yeah,
I mean,
almost
our
none.
power sports speakers are, but that's a different application. So this is why it gets really important to understand how the bridging works and what the amplifier is going to see as far as output power. So let's go back and look at it one more time, just kind of give you a refresher. So let's take the 4 ohm speaker and we're going to connect it to this amplifier, which this was the 404, so it's doing 50 watts by 4 at 4 ohms. But once again, it should do 100 watts by 4 at 2 ohms. And then if you bridge it, it's actually going to do 200 watts by 2 at 4 ohms. So once again, I can get 4 times the power of the number of speakers. So 4 ohm speaker, equivalent to the 4 ohm resistor, which is equivalent to 2 ohms in series. Let's go ahead and break that connection. And of course, we're not going to connect all this in parallel. So now you can see how that 4 ohms mono is exactly the same as 2 ohm stereo, because these two terminals are identical. They're actually tied together in the amplifier. So that's what happens when you bridge amplifiers. Strapping is a little bit different. So how does this actually work? Why do we get these two channels here, and why does it give you more output? So if we take this amplifier that's got a sine wave coming in on this channel and a sine wave coming in on this channel, they're referenced to ground. So what we're going to do is, you would think that these two would just pretty much cancel each other out, but we send this through an inverter before it goes out the speaker lead when you bridge it. So we bridge that, we're basically taking this and we're taking this, and we're going to sum them together to give us that greater swing versus the swing we had before. So it's pretty interesting the way it works. But for those of you that have always wondered how the amplifier works, why does the impedance always double when it's bridged versus stereo, and what does the amplifier technically see? Well, technically right now the amplifier is seeing 2 ohm stereo or 4 ohms mono. It depends, and it doesn't matter what the speaker is. I mean, if you put an 8 ohm speaker on this, you're basically going to have an 8 ohm mono or a 4 ohm stereo load. So it's always a factor of half or double depending which way you're looking at it.